Welcome to Maths and Science by IITian channel. I have started rotational motion for the last 3 lectures. 3 lectures are completed in rotational motion, wherein we have discussed about some velocity and acceleration formulae. And before proceeding further, we have to know about different quantities and definitions that are being used in rotational motion, which are different from the linear motion. Laws of motion may be same, but the quantities definitions are little bit different from the linear motion. One by one, we deal one after the other the linear motion for a particle and then rotational motion for a rigid body. We will move. First is for any particle, the position for any particle, the position and velocity are to be ascertained to know the state of the particle. And for that, let us say position is point P. It has coordinates as x, y and z. And this is the positional vector. Positional vector is from O to P. Now, this positional vector OP, we can also say it as R from O to P, that is the displacement, linear displacement. One is linear displacement, that is equal to OP, that is equal to R. Let me reduce the thickness of the pen by little bit. Linear displacement OP is equal to R. That's a vector. Displacement is a vector. Second, what is for finding the state of a particle, what we require? First is position, next is velocity, which I have told you in the first class, in the introductory class. It was about 1 hour 10 minutes. That's very, very crucial. Please listen to it. Linear velocity. Linear velocity is represented by v. That is also a vector. Whenever I put a bar on any quantity, that is a vector v. What is this vector? Rate of change of displacement. That means dr by dt. Third quantity is linear acceleration. It is denoted by A, that is d square r by dt square, or it can be dv by dt. This can also be written as A is equal to dV by dt. It's very important equation. dV by ds into ds by dt. Very important. If acceleration is given as dV by dt, then it can be written as dV by ds. dV by ds is nothing but gradient of the change in velocity with respect to space. Acceleration is change in velocity with respect to time, whereas gradient is change in velocity with respect to space, and this is change in displacement with respect to time. Can we write this as acceleration is equal to V dV by ds? Yes, we can write it as like this. This is a very important. If you know the velocity at a particular point of time, and if you know the gradient of the velocity, then you can get the acceleration. This is one of the important definitions which you are supposed to know. Now, next is, what is the momentum? Momentum is equal to it is a vector. It is written by p, small p. Mass into velocity. Mass is a scalar. It is a v is a vector. Please, it's also very important. And what is force? Force is a vector. Is rate of change of momentum. That is m into dV by dt. Can I write it as m into dV by ds into ds by dt? Yes, we can write. This can be m into gradient into velocity. That means force is equal to mv dV by ds. This also please remember. What is another is also there, it is also important. Another one, force is equal to m into dV by dt, which can be written as m into dV by dt. M into dV is nothing but change in momentum, that is p dot by dt, rate of change of momentum. That means force is equal to dP by rate of change of momentum. This is also very important derivation from definitions. And another one, m into dV by dt force Force is a very important parameter. M into dv by dt. What is dv by dt? That is acceleration. M into acceleration. That means force is equal to m into acceleration. This is also very important derivation. These are all very important derivations for mechanics. Don't forget them. Now, how acceleration can be written? Acceleration is equal to dv by dt, that is equal to what is v? Dr by dt. That means d square r by dt. This is also very, very important. Wherever gradients are given in the examination, use the gradients and gradient formula. Wherever rates are given, with the rates you go for the ds by dt, dr by dt, dv by dt. Whereas if it is a with respect to rate, with respect to space means it is a gradient. Please make the difference. Gradient formulas are different. Then angular momentum. That's very important. Which one? It is number 6. Number 6, angular momentum. Angular momentum is represented by capital L with a bar on it. It's a vector. L is equal to R cross P. This is a very, very important formula, where P is the momentum and R is the radius of vector from origin to the particle, like this. This is R and this is the particle. R cross P. L is equal to R cross P. The definitions of the cross product and dot product I have already explained in the vectors section. Please refer to them. And another is there, moment of force. Another one, very important, moment of the force. Moment means that quantity into distance is moment. It is 7th one. Moment of force. That is equal to represented by N, capital N. Capital N is equal to, it is a vector, moment of the force, R cross force, radius cross force. And what is the force? Force can be written as rate of change of momentum or cross rate of change of momentum. Momentum is mv This can also be written as d by dt into r cross mv. D by dt we have taken it out. Because I have already explained you in the previous class, when you cross multiply two products, two vector quantities, and take a differentiation, then d by dt of r cross mv is equal to v cross mv. Why it is v cross? Because d by dt of r is v. First from u dash v plus v dash u. Differentiation of uv is equal to u dash v plus v dash u. U dash means d by dt of r. D by dt of r is nothing but, we can even write differently. Similar thing we will write like this for clarity. D by dt of r cross second is mv. This is u, this is function f, this is function g. D by dt of f cross g is equal to d by dt of f into g is equal to f dash, this is f dash into g, plus g into f dash. F dash into g plus f into g dash cross d by dt mv. This is f and this is g dash. Product of differentiation of product of two functions. Then it implies d by dt of r is nothing but v cross mv. A cross A, what is it is? Its value is 0 because sin 0 is 0. If same vector cross product is equal to 0, here you write same vector cross product is equal to 0. Please make a note of it. Plus r cross d by dt of mv. This becomes 0. This is equal to r cross d by dt of mv. This is what we have got here. R cross d by dt of mv is equal to d by dt of rmv. Therefore, n is equal to moment of force is equal to d by dt of r cross mv is equal to r cross mv is nothing but angular momentum d by dt of r cross mv. Why it is an angular momentum? Because r cross mv is angular momentum. R cross mv. This is equal to r cross mv. r cross mv is angular momentum. This is d by dt of angular momentum L. That is equal to dl by dt. That is equal to rate of change of angular momentum is equal to, that implies, very important definition, rate of change of angular momentum is equal to moment of force. This is a very important concept we have developed. It will be used extensively in rotational motion. That is, N is equal to force moment is equal to dl by dt. In addition to that, it is 7th. Now we will go to 8th one. Another definition, important definition, work is equal to W is equal to F dot ds. F dot s. Either integral F dot ds, if it is an infinitesimal s if we take, or F dot s. That is equal to scalar. This is also very important derivation we should think of. Now, another thing also is there. Force is equal to, let me write it in advance, you please try to understand. Force is equal to minus dou v by dou a. That is gradient of potential energy minus gradient of potential energy. V is potential energy. Because I am talking about the gradients, I thought it will be prudent for me to express force is equal to gradient of potential energy. Now, we will move on to other definitions. What is the angular displacement? Linear displacement we have seen, yes. Angular displacement is equal to theta. Rate of change of angular displacement. Rate of change of angular displacement is equal to d theta by dt. That is equal to angular velocity. Very, very important parameter, omega. It's a vector, angular velocity. And 12th quantity, V is equal to omega cross r, where omega is the angular velocity, V is the linear velocity. Translational, it is rotational, which I have expressed in the previous class. And it is like this, and if it is d theta, and here it is dv, and here it is r, then V is equal to omega r. Omega is the angular velocity, r is the radial distance or radial displacement, and velocity is equal to omega into r. This, you please do not change the order. If I have made a mistake in the any previous classes like r omega, that you please neglect it. It is omega r, it is correct. Now, omega is equal to d theta by dt. Now, angular acceleration. Angular acceleration is equal to alpha. It is denoted by alpha. That is equal to d omega by dt. And force moment can also be called as torque. That is represented by tau. And 14, torque is equal to tau is equal to force momentum, not moment, momentum, force moment is equal to I into alpha. Here I want to make a note here. What is force moment? Units. Force moment is equal to N is equal to R cross F. If you talk about the units, it is Newton meter. What is the torque? Torque is equal to I alpha. What is I? Moment of inertia. Moment of inertia into R square. That is equal to ml square. Alpha is radians per second square. That is t to the power of minus 2. ml into t to the power of minus 2 into L. That is equal to ml into t to the power of minus 2 is mass into acceleration, that is force into distance, that is equal to Newton meter. That means the force moment N and the torque both have the same units. In some books, force moment is not mentioned, but if it is given in the examination, then please see that force moment is distance into force is force moment. Torque is, that is also force into distance, but that is I into alpha. I will tell you force moment what it is. A force is applied here and you want on a rod, you want to find out the movement about here. That means if this rod is here, if it is fixed, what happens? This rod is going to be rotated in this direction because of this force. If this is the distance F, this distance L is equal to R also we can say, this is F, then R cross F is equal to N. In case of torque, there is a rigid body and here is a point P, and some force is applied from here on the rigid body, external force, and external force is applied means force moment. Instead of force applying, we can say because of some external influence, this rigid body is rotating and it has got a moment of inertia as I, that is equal to mr square. Moment of inertia, and it is rotating about this axis, it is rotating about this axis, the rigid body is rotating. The rigid body has got a moment of inertia of mr square. Then when the rigid body is rotating with an acceleration of alpha, then this will be, torque will be, that is also like what you call, you can say, as if here external force is applied and a distance is known. Here moment of inertia is known and the rotation acceleration is known. Then torque tau is equal to I alpha. These two have the same units, whether it is force moment or whether it is a torque. Now, angular displacement you know, angular velocity you know, angular acceleration you know, linear acceleration, linear velocity, and linear moment of force is known, and angular torque is known. Now, what more we want to know is kinetic power and angular momentum and linear momentum. Linear momentum we have already seen, angular momentum also we have already seen. Let's go for power. Work and energy. Work also we have seen. Work is equal to dW is equal to F dot ds. Tau d theta. Now, next quantity is, please one by one, please try to understand. 15th quantity, work is equal to, work implies dW is equal to F dot ds. When linear motion is considered, the same is equal to tau dot d theta. This is when angular momentum is concerned. But the units you see, here force is Newton meter. Here torque itself is Newton meter. D theta is radians, it is like a dimensionless quantity. That means dimensions of both the units are same. That means equating force to torque is wrong. Force has a unit of Newton, whereas torque has a unit of Newton meter. Force is different, torque is different. For force movement, this is N is equal to Rf. That can be compared with the torque, not force should be compared with the torque, as far as dimensional analysis is concerned. Now, work is over. This is joules, the unit of work. Next is work and energy, both are scalars. Energy can be kinetic energy. Kinetic energy is equal to, in linear, what is that? K is equal to half mv square. Because it is a scalar quantity, we can have only magnitudes. Half mv square, it is also Newton meter. This kinetic energy is equal to in half I omega square. That is also kinetic energy is Newton meter. Newton meter is nothing but joule. And linear momentum I have already told you. Angular momentum I have already told you. Linear momentum is final one. Linear momentum is equal to P is equal to mv bar, and angular momentum is equal to L is equal to R cross P. Or it can be I omega. Let us check whether I omega and R cross P both have the same units or not, same dimensions or not. R cross P is equal to, only we are talking about the dimensions, L momentum is m L t to the power of minus 1, that is ml square t to the power of minus 1. And what about I omega? mr square, that is ml square t to the power of minus 1. Here we have forgotten another important quantity, that is moment of inertia. Moment of inertia is itself a very big topic. Moment of inertia and center of mass I will be taking up in the next class. Then we will go for some numericals. Moment of inertia is mr square. I is equal to, it is denoted by mr square. Your dimensions are ml square. M is the mass and r square is the distance. I think we will stop here. Don't get confused between moment of force and torque. Please, both have the same units. Torque and moment of force, both are same. Some books they call it, they omit moment of force and they take torque directly. Some books they take moment of force. It is up to you. Either you call them moment of force or torque. It is ultimately, when you use the force in the linear motion, then it is better to go for moment of force. That is That is better. When you are talking about the angular motion, then I alpha you take and that you take it as a torque. Don't mix up both. And the units of both of them are same. I is equal to mr square. That is the moment of inertia. That how to find out the moment of inertia, and that is the most important in rotational motion. And how to find out the center of mass, moment of inertia, they are all very, very important, and we will be dealing with them one by one. These units we will be dealing in detail one by one, because it's a very big topic, very big chapter. And in my lectures anywhere, if V is equal to R omega, R cross omega is written, please neglect it. V is equal to omega cross R. This is the correct one. And with this, what are the quantities we have learnt? Let us have just a brief one by one, and we will close this chapter. We will close this lecture. Linear displacement is equal to R, that's a vector. Linear velocity dr by dt, that's a vector. Linear acceleration dr square by dt square, that's a vector. dv by dt. Then acceleration is equal to dv by dt is equal to dv by ds if gradient is the given, velocity gradient, into rate of change of velocity, rate of change of displacement, that is equal to a is equal to v dv by ds. Don't get confused about it. And a is equal to d square r by dt. If rate of change of displacement is not given, only gradient is given and velocity is given, use this formula. Often to confuse in the examination, this type of questions are given, very important. Then linear momentum is equal to mv, and force is equal to m into rate of change of momentum, that is equal to m into dv by ds into v. This is also very important. And m into dp by dt. dp by dt is force. M into dv by dt, that's also force. Force is equal to m into acceleration. D square, dv by dt is nothing but d square s by dt square. What is dv by dt? dv by dt is equal to d square r by dt square. This also you keep in mind. Everything is interrelated formula. Angular momentum is L, that is capital L, and that is equal to R cross P, where P is the linear momentum, R cross mv. And moment of force is N, capital N, that is equal to R cross F. That can also be treated as a torque, and that is equal to d by dt of R cross mv is equal to R cross d by dt of mv. Hence, N is equal to d by dt of R cross mv. This is the final equation. Then N is equal to d by dt of R cross mv, that is equal to d by dt. R cross mv is nothing but L. d by dt of L. That means rate of change of angular momentum is equal to moment of force. Moment of force can also be dimensionally equal to torque. Then work is equal to f dot ds, integral if it is a ds, then f dot s, that is a scalar. Then force is equal to, this is very important, potential energy by ds minus, because potential energy with height increases from the earth, and if height it is minus g towards the center of the earth, minus g towards the center of the earth. Hence it is minus dou v by dou s. Angular displacement is theta, rate of change of angular displacement is angular velocity omega, v is equal to omega square r, and angular acceleration is equal to alpha is equal to dw by d omega by dt. Torque is equal to N is equal to force moment is equal to I alpha, And then force, moment and torque both have the same units, Newton meter. And these are work units also, energy units. N is equal to R cross all force, R cross F, and tau is equal to I alpha. I is equal to moment of inertia, that is equal to mr square. And work is equal to dw f dot ds, that is Newton meter. And work is equal to, that can also be torque into d theta, torque dot d theta, that is also Newton meter, that is in joules. Kinetic energy half mv square, and kinetic energy in angular is a half I omega square. Then P is equal to mv, that is linear momentum, and angular momentum is equal to r cross p, that is equal to I omega. R cross p is equal to dimensions ml square t to the power of minus 1, and I omega is equal to ml square t to the power of minus 1. Moment of inertia I is equal to mr square, that is dimensions are ml square, and velocity is equal to omega square cross r. This is what in this class. I want to close this class now, and these units, these dimensions, and these equations I will be extensively using in the from the next class onwards, and explain the rotational motion. Best of luck to everybody. Thank you for listening to me. Thank you for viewing my lecture. My channel is Maths and Science by IITian. Please, if there is a value addition to your knowledge because of this video, please share and view other videos also, and subscribe to my channel. I will give the playlist link in the description so that you can view the other videos from my channel. Thank you for seeing. Best of luck to everybody.